Welcome to Aqualink Japan, a revolutionary undersea glass transit mega project.
This ambitious project aims to connect Japan's mainland with its northern islands.
A high-speed train emerges from a coastal terminal, preparing for its deep journey. Beneath the cold northern waters, a massive engineering marvel is taking shape.
For centuries, humanity has dreamed of crossing the sea safely and quickly.
Traditional undersea tunnels are dark, hidden deep within rock and clay.
Imagine traveling through a completely transparent world beneath the ocean waves. This video explores the bold vision of a glass-enclosed undersea transit system.
A concept that combines advanced marine engineering with futuristic design elements.
The project relies on curved, pressure-resistant glass and steel titanium supports. Japan's expertise in precision engineering makes this fantasy feel entirely believable.
The monumental task begins simultaneously on both shores of the strait.
Heavy machinery prepares the mainland coastal site for tunnel excavation.
On the northern island, engineers prepare the portal to receive the transit line. Before construction can begin, a comprehensive seabed survey must be conducted. Survey vessels use advanced sonar to map the complex underwater topography.
Geotechnical drilling rigs extract core samples to analyze the seabed layers.
Remotely operated vehicles deploy sensors to measure powerful ocean currents.
Engineers study the data to find the most stable path for the tunnel. Landside excavation begins, carving out the approach tunnels toward the sea. Robotic nozzles spray concrete to reinforce the newly carved tunnel walls. Workers install massive steel reinforcement grids to ensure structural integrity. Waterproof membranes and drainage channels are meticulously fitted inside. These approach tunnels form the realistic backbone connecting land to sea.
Meanwhile, the transparent tunnel modules are fabricated in specialized facilities.
Massive titanium rings are machined to incredibly precise tolerances. Automated welding systems assemble the circular structural frames.
Specialized factories manufacture curved, multi-layer, pressure-resistant glass panels.
Each glass panel undergoes rigorous quality checks to detect any flaws.
The assembly process begins by mounting the titanium rings onto a frame.
Suction rigs carefully lift and insert the curved glass panels into place. Waterproof polymer gaskets are compressed along the edges of each panel. An advanced anti-leak gel is applied to seal every connection perfectly. Circular end flanges are attached to allow modules to connect later. The completed module is moved to a high-pressure testing chamber. Pumps simulate the extreme pressures of the deep ocean environment. Sensors monitor the structure for any signs of stress or deformation. Once approved, the massive module is carefully moved to the dock. A heavy-duty crane lifts the module onto a transport barge. Tugboats tow the barge offshore to the designated installation site. Floating cranes prepare to lower the heavy structure into the sea. On the seabed, concrete anchor bases have already been prepared.
ROVs clear the area and place anti-scour rock around the foundations.
The transparent module is slowly lowered through the deep blue water. ROVs guide the descent using powerful lights and robotic arms.
The module hovers precisely above its prepared seabed foundation.
Hydraulic clamps secure the module firmly to the concrete anchor bases. The next transparent module is lowered, aligning with the first. Engineers guide the circular flanges together with millimeter precision. Waterproof gasket rings are compressed tightly between the two sections. Robotic arms secure the connection, bolting the flanges together underwater. A protective sealing compound is applied over the external joint. Pressure sensors verify that the connection is completely watertight. One by one, the modules form a continuous, transparent corridor.
Emergency flood doors are installed at the critical transition zones.
Drainage channels and powerful sump pumps are integrated into the floor. Laying power conduits and communication cables are run along the structure.
Ventilation ducts are installed to ensure a constant supply of fresh air.
Watch the alignment.
Monitoring cameras and leak sensors are positioned throughout the tunnel.
Vibration isolation pads are laid down to support the rail bed.
Workers install the heavy steel rails along the concrete floor.
The power rails and signal sensors are connected and calibrated. Engineers conduct safety tests on all electrical and monitoring systems.
An unmanned inspection vehicle is prepared for the first trial run.
The vehicle rolls slowly through the tunnel, scanning the glass walls.
Sensors record vibration, alignment, and structural behavior under load.
The train glides smoothly through the glowing, transparent tube.
Temporary construction equipment is removed as the project nears completion. Specialized cleaning crews polish the curved glass to perfect clarity. The blue underwater lighting system is activated, illuminating the sea.
They board the train, marveling at the spectacular views of marine life.
The train speeds through the glass tunnel, turning imagination into reality.